speaker in this session is Dr. Yuri Clement from Trinidad and Tobago. Dr. Clement is a pharmacologist. He holds the post of senior lecturer in pharmacology at the University of the West Indies, Trinidad and Tobago. His interest is mainly in herbal medicine research. When it started in 2002 and he subsequently became part of the organizing committee of the 6th and 7th of Caribbean Association of Researchers and Herbs, herb practitioners. And he is also interested in traditional medicine. He is working on this as a pharmacologist. And it will be very interesting to hear from him what the situation is in relation to cancer and perhaps future drugs which will combat cancer, which may come from study of herbal medicine. Yes, Doctor.
Thank you very much, Chair. And I would like to thank the Brazilian Academy of Sciences and the Brazilian National Academy of Medicine for the invitation, and also the sponsors for putting together this illustrious group of scientists and doctors in public health. Well, I think Dr. Allen did talk about the Caribbean yesterday, and in our context, when we talk about the Caribbean, we talk about the English-speaking Caribbean, and that will consist of islands like Jamaica, Barbados, Trinidad, St. Lucia, and sometimes we tend to forget that there's also Cuba and there is Puerto Rico, but sometimes we don't see the connection because of the language barrier. So what I'm going to talk about this afternoon is mostly what's happening in the English-speaking Caribbean, in Trinidad and Tobago, Jamaica, Barbados, where the University of West Indies is located. Alright, I want to say that my area, as the chair mentioned, is mostly in herbal medicines. And we know that herbal medicines have been around for centuries, and that many of the people in the developing world, they use herbal medicine as their major form of healthcare. And we also know that in the past that many of the drugs that we use today are derived from herbs, from plants that people would have used for health maintenance, also for treatment. And in the last few decades, we know that in North America and in Europe, there has been a major shift in how people try to direct their own health outcomes. So there's a big shift now in people taking herbal medicine, people doing acupuncture, people doing a lot of these alternative remedies to try to restore health. And because of that, we also see that the drug companies are also trying to see whether these herbal medicines, these herbal remedies, whether they can find new drugs. Because we know that over the last decade or so, there are fewer drugs that are being developed, there are fewer drugs coming to market, and therefore they need to find new sources of getting these medicines. I know that a lot of the thought that I've gone before would have been on public health and epidemiology, but this one I'm going to talk about is mostly on basic research in the lab, doing experiments on cancer cells. But in the Caribbean, we have a similar problem with the rest of Latin America, where we have some of the major killers, major conditions being cardiovascular. You have diabetes, and of course you have cancer. In Trinidad and Tobago, cancer, I believe, is the second leading cause of mortality, and we have three major, the three top cancers would be breast cancer, prostate cancer, and colorectal cancer. In pharmacology, you want to find drugs which are able to either inhibit the growth or kill the cancer cells with minimal effect on normal tissue. And we have seen in the past that many anti-cancer drugs were derived from plants. And there are a few of them in this plant. It has two compounds which was semi-synthetic. The original compound was modified a bit to produce these two compounds that are now available for cancer therapy. They are in the class podophytotoxins, and they are used for various types of cancers. The periwinkle have been around, and actually in Caribbean we have the periwinkle plant as an ornamental plant. It's being used to beautify people's gardens, and Around the same time, when they discovered these two alkaloids in periwinkle, I think there was another study going on somewhere else where they actually found the alkaloids vincristine and vinblastine, which are now used in cancer treatment. But in the Caribbean, we were actually looking for anti-diabetic agents in periwinkle. So I suppose if we had thought about looking at it for cancer purposes, then we may have been involved in the discovery of vincristine and vinblastine. Another plant that has given us a remarkable anti-cancer agent is the Pacific yew tree, and in the US for many decades they have been researched by the National Cancer Institute, where they came to the tropics and they carried back thousands of plants, extracts, and they used probably over 100 different cell lines. And what actually this paclitaxel has been around for many years, and it has been around because I believe that people didn't see the interest in it, and after some time they gained more and more interest, and it actually came on stream probably 3 decades after it was first discovered. And there was a biodiversity issue because you need large amounts of the raw material to actually produce very small amounts of the isolated compound. And therefore eventually they actually had to synthesize this compound so that you can actually be able to supply the demand for this drug. So there is a biodiversity issue when we talk about looking at new compounds, new drugs from plant material, because it means that if you have to harvest and actually probably carry plants to extinction. So that's part of what we also have to take into consideration when we're looking for new drugs from plants. At my unit, for a few years, we have been looking at, we start on a very small scale. We have one cell line that we work on, and we screen that cell line with a number of different plants, extracts. Normally what we will do is that we will probably select plants which have some sort of medicinal use, or a plant which at random we might select. And over the years we have screened about 20 plants or so. We normally will carry the plant to the herbarium where they will identify the plant. We will make a voucher deposit. Once we do that, we will now prepare the plant for extraction. We will wash, we will dry, and then we will mill, and then we will extract with methanol. And we have these plants, these are some of the plants that we looked at, and you will see that in some of those plants are plants which are endemic to the region. So normally what we'll do, we collect the first plant, we will go to the herbarium again, identify it, dry it, and we will extract with either water or methanol. With methanol, what we get is a solution which has to be, the methanol has to be evaporated, so we actually get a very gummy residue, and that residue is filtered, and then it dissolves again in water or saline before it is used in the experiment. And that, at the end of that, we have what our crude methanol extract. We also, in extracts, the crude extracts which we see some potential, we'll carry it a bit further, and we will do further fractionation to see where the activity is. So we'll have chloroform, ethyl acetate, butanol, and petroleum ether extracts. And we will use those extracts in those plants which have activity to see where the cytotoxic activity might be in those plants. So we did, as I said before, we do have one cell line, it's a T cell leukemia cell line, and that was obtained from a lab in the US. Normally it is kept, it is in a minus, it's in liquid nitrogen, and then ever so often when we need to do culture, we will take a sample out and grow it up in media to be used in the experiment. So normally it's in the experimental stage, it's incubated in carbon dioxide and subcultured twice weekly, and we harvest cells for the experiment 24 hours after subcultural. We will normally use a certain number of cells in the titer plates, and it's about 40,000 cells that we will use in each one. So normally the maximum volume that each plate will contain is about 200 microliters, which is about 1/5 of a mil, and that volume will contain the extract, the cells, and the media that it will grow in. Normally what happens is that we will have a negative control, which will contain no extract but just cells, and we have another blank which will contain the media and cells. So then therefore, and those controls are used to compare what happened when we gave the extracts. So therefore we have an idea of how effective or what effect that the plant extract would have on the cells and their growth. Alright, so we do a very simple test called the MTT test, and that MTT is this long compound here, 3,4,5-dimethyl thiazole 2,5-diphenyl tetrazole bromide. And really what it does is that compound, in living cells there is an enzyme, a reductase enzyme, which causes it to be converted into a colored compound. And that colored compound in a living cell is what you see under the microscope, or what you see visually. And therefore, when we give the extract, if the extract has cytotoxic activity, which kills the cell, it means that that enzyme that's present in the cell is no longer there, and therefore you wouldn't have conversion of MTT to this colored compound. And therefore we can actually measure the level of toxic response that we will get from the extract. So cell survival will let it be a ratio between the optical density in the wells that are treated with extract over the optical density of the control cell, the control wells, and those control wells will contain only the cells and the media, and it's a comparative between the extracts and the